Hello, fellow A&P nerds. Yes, that was just me whistling the theme to the TV show Sherlock. Now, why would I do that? Well, this little lecture I like to call Practice with Acidosis and Alkalosis. And I begin with a quote, "It is a capital mistake to theorize in advance of the facts. Always good advice for anyone." And another quote, "When I have eliminated the impossible, whatever remains, however improbable, must be the truth." These are two quotes attributed to the most famous fictional consulting detective Sherlock Holmes, as written by Sir Arthur Conan Doyle, who, by the way, had a medical degree, a clinical healthcare professional, yes, and the character of Sherlock Holmes based on one of his professors. Who would have thunk it? Particularly the second quote is important for us in our discussion of acidosis and alkalosis as conditions that a person might have. So keep in mind this second quote, "When I have eliminated the impossible, whatever remains, however improbable, must be the truth." Because what you have to do in this little exercise today is make like a detective. You don't have a Watson, you have me. So let me fill the role of Dr. Watson for you. So let's start talking about this a little bit. Here we see a chemical equation. This is typically known as the carbonic acid equation. And you can see that we have carbon dioxide, CO2, combining with water in the presence of an enzyme called carbonic anhydrase, Ca, to form what is known as carbonic acid right here, which then quickly dissociates into free hydrogen ions and bicarbonates. The hydrogen ion for us here is key in this equation. Now, as an A&P student in your second semester, you may already know that this happens several places in our body. Now, what I'm going to do right here is draw that biconcave disc we know as a red blood cell. And the CO2 comes into this cell. CO2 from where? Well, CO2 from converting pyruvates into acetyl-CoA and from the double run of the Krebs cycle. So this is from our cellular activities, in other words. And we convert this carbon dioxide that we produce as metabolic garbage into bicarbonates. You probably already studied that the bicarbonate that exits the red blood cell, little chloride shift to keep everybody electrically neutral. But what we also get are hydrogen ions. And the more hydrogen ions we end up loose with in our fluids, the more acidic we become. Because you might recall pH, don't want to get too chemical here, is a measurement of the hydrogen ions we have. That's where the H comes from. Now, to understand what's going on here, you have to think about what would happen the more CO2 we have. So the more CO2s that I have out here, the more this reaction will skew to the right. For the chemistry lovers, this is Le Chatelier's equilibrium principle, right? If you get more CO2, you're going to end up with more loose hydrogens. So more blood CO2 means more loose hydrogens, which means more acidity or a lower pH. because remember our pH scale goes with 7 in the middle, down, these are the acids below 7, up, these are the bases above 7. You might remember that from your study 7 being perfectly neutral, right? That's 7 right there, making a mess out of my picture, but that's okay. So what we have to do is use our respiratory system to convert all these bicarbonates we make back into CO2s and blow them out. So we can use our respiratory system to manipulate pH a little bit by blowing out more and less CO2. If you imagine somebody respirating, if we imagine someone respirating like this person right here, we'll make them a mouth breather just for our example. So the more CO2 we blow out through ventilation, the less CO2 we have in our blood. Because that's why we're blowing it out, to reduce it in our blood. But what happens if I don't blow out the CO2? See, I can do this with my tablet. I can just erase this. Maybe I'm hypoventilating, so I'm not blowing out the CO2. Then there's going to be more CO2 in my blood, more hydrogen ions, more acidity. So as blood CO2 goes up, blood pH goes down. Now, I would think you've probably covered this in your lecture, but that just follows this carbonic acid equation. So if the blood CO2 is high, hypercapnia, that's called, if you've never heard this term before, hypercapnia, if blood CO2 is high, then blood pH drops. I become more acidic. If blood CO2 is low, see again, I can just erase these. If blood CO2 is low, hypocapnia, then blood pH will go up. If I do not have CO2s in my blood, then the reaction skews the other way, to the left. So we can use the respiratory system as a physiological buffer. You have or will cover that in your lectures, I'm sure. But we can also use it to determine the cause of somebody's acidosis or alkalosis. Let me try and explain a little bit. And we'll work some practice problems here. So the normal blood pH range for a human is about 7.35 to 7.45. Seems like a fairly narrow window here, but it's not that narrow when you consider the pH scale is based on powers of 10. But this is the normal pH range, 7.35, 7.45. And I'm going to draw it again. Remember our pH scale. Anything above 7, base or alkaline. Below 7, acid. This is our normal pH range, which is close to neutral, just a little skewed to the base side. So clinically, we will say any pH a person's blood has that is below 7.35 is called acidosis. They have a condition of acidosis. Anything that's above 7.45 is alkalosis, condition of being alkaline or too basic, condition of being too acidic. So below 7.35, acidosis, above 7.45, alkalosis. So our first problem goes like this. So a person has a blood pH of 7.47. Now what I like to do is I always write my information so I can always see it to refer to. I can memorize this. This is the normal range, 7.35 to 7.45. This is acidosis down here, alkalosis up here. So 7.47, they have alkalosis. 7.32, they have acidosis. That's simple. So if I know somebody's blood pH, I can determine if they're normal or they have acidosis or alkalosis. Anything below 7.35, acidosis. Anything above 7.47, alkalosis. Anything between 7.35 and 7.45 is normal. That's probably where we are right now. Acidosis or alkalosis can be caused by your respiratory system if it's not functioning correctly. If your respiratory system is broken, you could end up with acidosis or alkalosis that is caused by your malfunctioning respiratory system, called respiratory acidosis or respiratory alkalosis. So one cause of acidosis or alkalosis is the respiratory system. If the respiratory system is not the cause, now look at how I wrote this, everyone. Acidosis or alkalosis can be caused by the respiratory system or by anything else in the world. Doesn't matter what it is. Anything else in the world. If it's not the respiratory system, it's called metabolic acidosis. If it's not the respiratory system, it's called metabolic alkalosis. So let's say a person has a blood pH of 7.48. Now, again, I always like to write my reference numbers down every time I think about one of these questions. 7.35, 7.45, what does this person have? Alkalosis. And their respiratory system is just fine. Then they have metabolic alkalosis. I don't care what the cause is if it's not the respiratory system. It just gets the name metabolic because you might recall metabolic means any of the body's chemical reactions that happen at all. So anywhere, any kind of chemical reaction in the body that's not the respiratory system, it's metabolic. It's sort of the default answer when it's not the respiratory system. I think you're going to get the hang of it as we go through a few of these. The easy thing to do for us is to either rule in or rule out the respiratory system. If it is the respiratory system, then the condition is respiratory acidosis or alkalosis. If it is not the respiratory system, it's metabolic. I don't care what the cause is. After that, for my, A&P course, I don't have to determine what the metabolic cause is. I only have to determine is it or is it not the respiratory system. I often tell people to think of getting that old jury summons and you get selected to be on a jury, kung kung, that's my Law and Order sound effect. So sitting at the defense table, you're going to have a lawyer and you're going to have the accused party right here. Now, you're sitting over here. Oh man, I don't know if I can draw this, but I'll give it a shot. So bear with me, people. So you're sitting over here, where? In the jury box, of course. Here's you. You got picked for the jury. That's stick you right there. So here's my question for you. If you're sitting in a criminal case, you're the juror, do you have to decide who did it? Do you have to figure out who done it? No, all you have to determine is, did this person do it? If you think this person did it, you vote guilty. If you think this person did not do it, of course, beyond a reasonable doubt, I understand the American justice system, not guilty. That's your only choice, isn't it? You're not supposed to figure out who did it. You're just supposed to determine, did this person do it? Well, my example hinges on this. You're in the jury and the defendant is the respiratory system. So all you have to determine is the respiratory system guilty or is the respiratory system not guilty of causing acidosis or alkalosis? So we use the pH to determine if a person has acidosis or alkalosis. Then we use their blood CO2 or the partial pressure of carbon dioxide. I'm assuming you know what this is, partial pressure of carbon dioxide, before you watch this video, and or their respiratory rate to decide. If a person has respiratory acidosis, they're going to have a high blood CO2. They're going to have hypercapnia. This is the definition of respiratory acidosis. They have a high partial pressure of CO2. The more CO2, the higher the partial pressure. Go back and review your respiratory system notes if that doesn't make sense. They would have a low respiratory rate. They would be hypoventilating. Now, acidosis, this is when the pH is low, right? Below 7.35. Notice something here. Maybe you picked up on this. Let me just change colors. See what the respiratory rate is? It's low. See what their pH is? Low. If the respiratory rate and the pH match, it's respiratory acidosis. By the same token, respiratory alkalosis, pH is above 7.45. pH is high. This person's going to have low blood CO2, hypocapnia, low partial pressure, high respiratory rate, hyperventilation, I can use the same example here, high above normal ventilation rate, high above normal pH. If the respiratory rate and the pH match, they're both high, it's respiratory alkalosis. You can also look at it this way. The blood CO2 is the opposite of the pH in both cases. The ventilation rate is the same as the pH in both cases. This is what makes it respiratory acidosis. So if they have acidosis and they have this, it's respiratory. If they don't, it ain't. Then what is it? Metabolic. If they have alkalosis, low blood CO2, and or a high respiratory rate, it's respiratory alkalosis. If they don't have these things, it's not respiratory alkalosis. Then what do I call it? Metabolic. If it's not respiratory, then it's metabolic. I think you'll get it after we work through a few. So let's work through a few just for fun. So here we have Jay Schmo is our patient. So notice what I did here was I made 2 blanks for us. So just on this first one, the first word is going to be respiratory or it's going to be metabolic, depending on the cause. And over here, I'm going to have acidosis or alkalosis, the condition the person has. So I'm going to write my information down over here that I use. So I remember 7.35 to 7.45. That's my normal pH range. What's this person have? 7.33. So I already know they have acidosis. I hope you all see where I got that. Their pH is below 7.35. That's the acid side. So whatever they have acidosis because they're outside the normal blood pH range. Now, if it's respiratory acidosis, I expect their blood CO2 to be high. I expect their respiratory rate to be low. That's if it's respiratory. Blood CO2 would be high. Respiratory rate would be low. What's their respiratory rate? Low. What's their blood CO2? High. They have respiratory acidosis. Done. I just make a decision. Now notice these 2 facts. I give the person's shoe size, 10.5. Does that have anything to do with anything? No, of course not. Their urine is very acidic. Our kidneys tend to compensate for acidosis all the time by dumping hydrogen ions into our urine and holding back bicarbonates. So this is totally expected, but it doesn't have anything to do with me making my decision. So first I decide, is it acidosis or alkalosis? This is acidosis. Then I determine, is the respiratory system causing it? The answer is yes, because it meets my criteria. It's respiratory acidosis. I'm done. Do another one. J. Doe, a female patient with blood pH of 7.48. Well, let me write down my info again. 7.35 to 7.45 is how I determine acidosis or alkalosis. Acid over here, alkalosis over there. What's her pH? 7.48, that's alkalosis. I've already done half of it already. In respiratory alkalosis, I expect blood CO2 will be what? Low or high? It's going to be low. and I expect respiratory rate to be high. Let's check this one out. Blood CO2 is very low. Respiratory rate is very high. This does match my criteria. This is respiratory alkalosis. The fact that this patient has excellent taste in movies makes no difference at all. That's just a nice thing to know. What do I look at? The blood CO2 and the respiratory rate to determine if this is respiratory or metabolic acidosis or alkalosis. Let's keep working. J average. Now, I like to jot down my info again here. So 7.35 to 7.45. Acidosis over here, alkalosis over there. This person has a blood pH of 7.42. Well, that's in the normal range. They don't have anything, do they? This person is normal. They don't have acidosis or alkalosis. Their partial pressure of CO2 is perfectly normal. Their respiratory rate's a little high, but so what? Their blood pH is normal. They do not have acidosis or alkalosis. This is a normal person, at least with regard to their blood pH. J-Fizz. Now, notice I just always do it the same way. So here's my 7.35 to 7.45. Alkalosis over here, acidosis over here. 7.30 acidosis. This person has acidosis. Now, respiratory acidosis, I expect respiratory rate would be very low, hypoventilation. I'd expect blood CO2 to be very high if it's respiratory. So let's check it out. Their respiratory rate is very high. Whoa, 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 nope. Their blood CO2 is low. No, 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 no. They don't match, do they? This is metabolic. Now, what could have caused this? Oh, I don't know. Maybe they drank some antifreeze. That would do it. Maybe they worked out and had such a big lactic acid buildup. Maybe they made a bunch of ketones. You know what? It could be any number of things. I don't care what it is. That's not our function today. It's just to determine, is it respiratory or metabolic? Because they don't meet the respiratory criteria, it has to be metabolic. Now, when you advance people and you want to diagnose the cause, yes, you could look at that anion gap, the difference between the sodiums and the chlorine and bicarbonates, and determine and do a case history and all that stuff, you know, blah, 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 healthcare stuff. We don't care about that right now. Today, we're just trying to determine, does this person have respiratory or metabolic acidosis? They have acidosis. It is not caused by the respiratory system, so it is metabolic by default. Now, notice that these two things, the respiratory rate and the blood CO2, are abnormal, aren't they? But they aren't what go with respiratory acidosis. Just because the respiratory rate and the blood CO2 are abnormal does not mean the respiratory system is the cause. They have to match. Low blood pH, low respiratory rate. That's not what they have. High blood CO2, that's not what they have. Can't be the respiratory system. What's happening here is the respiratory system is trying to compensate for it. So this person is hyperventilating, trying to fix their acidosis. The respiratory system isn't the problem. The respiratory system is trying to fix it. But all we have to do is see if they match. If it doesn't match my criteria over here, it's not the respiratory system. So this person, JFizz, has metabolic acidosis. And of course, their favorite color doesn't have anything to do with anything. J College. Blood pH, 7.48, I see. Now again, 7.35 to 7.45 is the normal range. Alkalosis, and I can't spell today, sorry. Acidosis, down here. 7.48 is alkalosis. Now, before I look at anything, I want to refresh my memory. Let's go all the way back up here. If a person has respiratory alkalosis, low blood CO2, hyperventilation. So if the alkalosis is from the respiratory system, what do I expect to see? Hyperventilation, low blood CO2. Is this person hyperventilating? No. Do they have low blood CO2? No. What's the cause of their alkalosis? I don't care, but it's metabolic. Maybe they ate too many greens today. Maybe they have a kidney problem. Maybe they have, I don't know what it is, but it's not the respiratory system, whatever it is. Are you getting the hang of this? This is the way you should do it for every one of these problems that you're presented with in your A&P semester. And the fact that they have a 98.4 body temperature doesn't mean anything. Let's do one more. This patient, a 45-year-old woman named J. App Lab, which of course we know means A&P Lab, mother of two. That's very nice, but it doesn't have anything to do with her condition if she has one. So 7.35 to 7.45, alkalosis up here, acidosis down here. 7.29, oh, that's acidosis. So she has acidosis. If it's the respiratory system, acidosis would be caused by hypoventilation, high blood CO2. That's what I expect to see. What does she have? Oh, she's hyperventilating, isn't she? She's got very low blood CO2. That's not the respiratory system, is it? This is the metabolic acidosis. Do you see that? This is metabolic acidosis because the respiratory system is not causing it. I don't care what the cause is if it's not the respiratory system. Now, what I would suggest you do, if you're not getting this, this is why I'm putting this video up, you can start back at the beginning, and even if you don't get the bit about the red blood cell and the carbonic acid equation, that's okay. Make sure you learn to determine acidosis versus alkalosis, and then is it respiratory or not. Because if it isn't respiratory, then it's metabolic. So you can go through this video again slowly, determine for each person, use the pause button. Do they have respiratory or metabolic, acidosis or alkalosis? So you notice I always determine, is it acidosis or alkalosis first? Then I look to see if the respiratory system is the cause. If you go through this 3 or 4 times, hopefully, knock on wood, that's me knocking on wood, you'd be able to answer a question on a lecture test to determine, is a person's abnormal blood pH caused by their respiratory system or something else, which is metabolic. So I hope this helps you out. Again, this is designed so you go through it several times, pausing me to answer these questions about each one of our fictional patients. Okay, so I hope this helps you out. Practice a little bit. It's not that bad. It just looks bad. I'll see you in the next little lecture.